Okay, so I have to confess something.
Huh?
I was trying to learn a new language last week. I won't say which one. And the app I was using, it gave me this badge
A badge for what?
for logging in 3 days in a row. And I felt this, this real rush of dopamine, like, yes, I am achieving.
Right, the little reward hit.
But then it hit me. I hadn't actually learned a single verb. I just opened the app.
And that is the classic gamification trap right there. We mistake the points for the actual progress.
Exactly. And it's everywhere now. My banking app has a progress bar. My watch gives me fireworks for standing up.
And at work, the mandatory training modules.
Oh, the training modules, where you're like a cartoon detective looking for compliance violations.
The promise is so seductive, though.
Yeah.
If we make work feel like a game, it becomes fun, effortless.
But, and this is why I wanted to do this deep dive, I feel like 90% of the time it's just bad. Cringy or boring, or you play it and 5 minutes later you've forgotten everything.
You are definitely not alone in that feeling. We are, I think, standing in a massive graveyard of educational games.
A graveyard.
We see the big hits, your Duolingos, your Minecraft education editions. But for every one of those, there are thousands of projects that burned through millions of dollars, launched, and were then completely ignored.
So, being the nerd that I am, I wanted to know why. Is it bad coding, bad graphics? And I dug up this huge study from France.
Right.
It's by Quentin Alvarez and his team, titled RDU Model, dedicated to evaluate needed counsels for serious game projects. And when I say huge, I don't mean they looked at 3 apps on the App Store.
No, this is a serious longitudinal study. They analyzed 150 different projects.
150.
Over 15 years, from 1998 to 2013. And we're talking heavy hitters. Orange Labs, TF1, the National School of Civil Aviation. This is basically a 15-year postmortem.
And the mission for this deep dive is to figure out what went wrong. The paper proposes this thing called the RDU model, which sounds super technical.
It does, but it's not. It's really this fascinating roadmap of failure.
It basically says your code is fine. It's your ecosystem that's broken.
That concept of the ecosystem is the key to the whole thing. The Alvarez paper argues that we tend to treat software like an island.
Right.
But it lives in a world of people and politics and institutions.
So before we get into the failures, and we have some spectacular ones to talk about, we should probably define what we mean by a serious game. Is that just a fancy word for edutainment?
It's a bit more specific. The paper defines it as an artifact, where the intention is to combine 2 things. A utilitarian function, so teaching, training, that kind of thing.
Yeah, with gameplay.
Exactly. They literally write it out as an equation. Serious game, utilitarian function, plus game.
Looking at that, you'd think, okay, simple enough. I take a math lesson and I add a spaceship blaster. Done.
And that is the trap.
The chocolate-covered broccoli problem?
That is a perfect analogy. The paper points out that designers just obsess over the object, the game itself. They think if they build a good engine, the learning tack can have.
By magic. But it's much messier. So the researchers came up with this RDU model to explain the mess. RDU.
This stands for realization, dissemination, and use.
Okay.
Realization is making the thing. Dissemination is getting it out there.
And uses, making sure people actually get it.
Precisely. Ensuring they understand what they're doing.
It sounds like a standard product life cycle.
Yeah.
But they identify what they call counsels at each stage. Now, that word counsel, it sounds a bit legal.
Yeah, it's a bit of a translation artifact. Don't think of a lawyer. Think of them as support systems.
Support systems, that works much better. Or guardrails.
Or even just missing links. These are the human or organizational resources you need to make the tech actually work.
Okay, so let's start with R for realization. The building it phase. I assume this would be the easy part. We know how to make video games.
Well, it's hard because in a serious game, you're serving 2 masters who hate each other.
The fun and the lesson.
Exactly. You have the ludology, that's the rules, the fun, and you have the educational content.
So the game designer is like, let's make things explode. And this subject matter expert says, hold on, we need a definition of photosynthesis first.
And that friction is deadly. The paper identifies design support as a critical missing system. It's a 3-way balancing act. Lean too hard on the game, people have fun but learn nothing.
Lean too hard on the education, and it's just a glorified pop quiz.
And everyone quits.
It's interesting they also list R1, gaming culture as a support system,
Hmm.
basically saying you need people who actually play games to make games.
You would be shocked how often that gets ignored. You get a committee of 60-year-old executives deciding what's a cool game for teenagers.
Which is a perfect segue to our first huge failure in the dissemination or D category. Let's talk about technosity. This case study made me physically cringe.
Technosity is the ultimate example of right product, wrong delivery.
What was it?
So this was back in 2006 in the Midi-Pyrénées region of France. The local government wanted to get teenagers like 15 to 18-year-olds into technical careers.
A noble goal.
A very noble goal. So they built this game on CD-ROMs,
Remember though?
and they shipped them out to 600 high schools. A massive rollout.
Okay, sounds good so far.
On paper, it's a success. The realization was done. The discs were mailed. But 9 months later, the researchers went to check on the impact. Crickets. Total silence. Most schools didn't even know they had the game.
How do you lose 600 CDs?
You don't lose them, you bury them. This was a failure of what the paper calls D2, marketing coaching. They just mailed the discs to the school librarians. No context, no posters, no instructions.
So the librarian gets this random desk, shrugs, and puts it in a drawer.
Or worse, they put it on the computers, but they used it as a digital babysitter. When a kid was being loud, they'd say, "Here, play this and be quiet."
But the target audience was 15 to 18. Did they play it?
They took one look and walked away. The graphics were really bright, colorful, very cartoony. The teenagers said, "This is for babies."
Ah, that stings.
So the only people who actually played Technosity were the 12-year-olds on their lunch break.
Who are too young to care about career guidance.
And the older kids who needed the guidance refused to touch it because it wasn't cool. The whole project failed because it lacked general adoption support. You can't just drop a tool into a school and hope for the best.
You have to sell it to the whole ecosystem.
To the teachers, the librarians, and the students.
Okay, so that was a school. Kids are picky, but surely high-level professionals are different. Let's look at the ATC project for the National School of Civil Aviation.
Air traffic controllers. Life or death stuff.
Exactly.
And that life or death seriousness is exactly why the project hit a wall.
What happened?
The developers built these games to help train controllers. But the instructors at the school, the experts, they flat out refused to use them.
Was the simulation bad?
No, the software was fine. The problem was the word game.
You're kidding me. Semantics.
It's more than semantics, it's identity. Air traffic control is a serious, high-pressure job. The instructors felt that calling their training tool a video game was insulting.
It trivialized their work.
They insisted, "We do not play games here, we run simulations."
But wait, if the software helps people learn, who cares what you call it? That feels like ego getting in the way.
It is ego, but ego is part of the ecosystem. This is what the paper means by D4, political support. You need a support system to manage the reputation of the tool.
So for Technosity, they needed marketing. For ATC, they needed a PR campaign to rebrand game to tactical simulation.
Precisely. You have to massage the ecosystem to accept the new organ.
Okay, let's move to the last letter. U for use. This one really surprised me because in my head, if people are playing the game, you've won, they're using it.
And that is the most dangerous assumption of them all. Just because the pixels are moving doesn't mean the brain is learning.
So there's a case study here called Flee the Skip.
A fascinating one. It was developed by Orange Labs, and the concept was actually really sweet. It's a 4-player game where you each play a defective mobile phone.
A defective phone. Okay.
So maybe your screen is cracked or your battery is dying. And to win, you had to cooperate, exchange energy, share data, help the slow players. The whole lesson was about solidarity.
So it's a game designed to teach empathy.
That was the plan. But then they tested it with a group of gamers. And if you know anything about the gamer mindset,
Gamers like to optimize. They like to speedrun.
they were efficiency machines. They saw the defective players, the ones who couldn't jump high, not as teammates to help, but
It's
as
bottlenecks.
exactly, as bottlenecks.
Oh no.
The skilled players realized they could win faster if they just ditched the slow players. They ostracized them. They left them behind.
That is dark. A game built to teach solidarity accidentally taught survival of the fittest.
It taught exclusion. And this wasn't a coding error. The social interaction failed.
So how do you fix that? Do you change the rules?
You could, but the paper says this was a failure of U1, use support. You needed a human component, a mediator in the room to pause the game and say, "Hey, stop." The goal isn't just to finish, it's to finish together.
That's such a key point. We think technology replaces the teacher, but here, it created a situation that required a teacher to step in.
Without that human use support, The game mechanics just completely overpower the moral message.
And we see a similar thing with the Gargus project for little kids tracing cave paintings.
Right, 5 to 10-year-olds. They had to trace the outline of a bison on a touchscreen before time ran out.
Sounds like fun.
It was too much fun. The kids got into a twitch frenzy. Faster, faster. They were so focused on the reflex action of tracing.
That they weren't looking at the picture, just the line.
Exactly. The researchers call this the filter effect. The gameplay acted as a filter that blocked the educational content. Afterward, they couldn't name the animals. They just knew they got a high score.
So again, you need that human support, someone to say, okay, put the iPad down. What did we just draw?
You need a debrief.
Yeah.
The learning doesn't happen during the game. It happens in the reflection after the game.
Okay, so we've bashed these failures pretty hard. Was there anyone in this 15-year study who actually got it right?
There were a few, but Dentistry Kid stands out.
Dentistry Kid sounds like a terrible superhero.
It was a training module for dental students to diagnose pathologies in children's teeth.
It worked.
Massive success. 75% positive feedback. Students learned faster. Teachers loved it.
Why? What did they do that Technosity didn't?
Integration. They didn't just email a link to the students and hope. They built the game into the official curriculum.
So the game and the class were actually talking to each other.
Exactly. The professors used the data from the game to see which students were struggling and then address it in the lecture hall.
But it wasn't perfect from the start.
No, even there they found a hiccup. Initially, students were frustrated because they were trying to learn dentistry while also struggling with the mouse controls.
Cognitive overload.
Right, so they had to add a layer of U1 use support. A quick tutorial phase where students just learn the tool before tackling the subject. Once they fixed that, it flew.
So this brings us to the big reveal. The researchers took all these projects, analyzed them against the RDU model, and counted up the missing support systems. What did the data show?
It's a really striking statistic. When they looked at the failures, they found that in the realization phase, the making of the game, there were only about 11 missing support systems across their main cases.
Okay, 11.
But when they looked at dissemination and use, the D and U families, there were 20 missing systems.
That's nearly double.
It just confirms the hypothesis so brilliantly. We are actually really good at building the software. We have the R down. Where we fail is the D and U.
The human side, the organizational side, the cultural side.
It's not a code problem, it's a context problem.
Every time.
Almost every time.
The paper makes a comparison near the end to Shannon's communication theory, which felt a bit abstract when I first read it.
I could break that down. Think of a radio station. You have this signal, that's the music, the lesson you want to teach,
Yeah.
and then you have noise, static, interference. The researchers argue that without the proper support systems, without the teacher, the debrief, the marketing context, the game part actually becomes the noise.
Wow, okay. The fun part becomes the static.
Exactly. If the game mechanics are too competitive, like in Flee the Skip, they just drown out the music. The player's so busy trying to win that they can't hear the lesson.
The support systems acts like the tuner.
They clear up the static so the message can come through.
That really changes how I look at these apps. We think, if it's fun, it's good. But if it's too fun, it might just be loud static.
It's the chocolate-covered broccoli problem all over again. If the chocolate's too thick, you never paste the broccoli. And then what's the point?
So for our listeners, what's the big takeaway? Most of us aren't building air traffic simulators.
The takeaway is the RDU checklist. If you are rolling out a new tool at your company or giving your kid a math app, don't stop at realization. Don't just buy the tool.
You have to ask about dissemination.
What is the plan? How are we introducing this? Is the culture ready for it?
And then ask about use.
Who is helping people interpret it? Is there a feedback loop? A debrief?
If you don't have answers for D and U, you don't have a solution, you just have a digital paperweight.
And you've probably wasted a lot of money.
Before we go, there was one final thought in the paper I found really provocative. They mentioned the difference between gamers and non-gamers.
Yes, the skill-play gap. This is something we really need to watch.
Because we are moving toward a world where everything is gamified. Healthcare, banking.
Civic duties, you name it.
Sure.
And the researchers note that gamers have a specific literacy. They understand how to navigate 3D spaces, they get HUDs, they know how to min-max. A huge portion of the population doesn't have that literacy.
So if we force everyone to use serious games for essential training or services,
we could be creating a new kind of inequality. If you need to be good at video games to effectively learn your job or manage your health insurance,
We're leaving the non-gamers behind.
That's a terrifying thought, really.
The digital divide 2.0.
It's something we have to design for. We can't just assume everyone speaks joystick.
Well, on that cheerful note, seriously though, this was an eye-opener. Next time I get a badge on an app, I'm going to ask myself, is this signal or is this just noise?
A very good question to ask.
Thanks for diving in with us. We'll catch you on the next one.